I have a 1,000 ml beaker with 500 milliliters of deionized water with 500 milliliters of vegetable oil. Right now I haven't mixed them together. I can see there's some bubbles just from when they were initially poured in there. One thing about this ring stand setup I noticed is it's leaning forward. That's actually more of a fault of the base, this plastic base of the ring stand, not of the stir, but it doesn't make any difference because, again, with the glass stirring shaft on a hook to freely swing, it's perfectly fine as far as its orientation. So what I'm going to do now, so again, we've got just deionized water, 500 milliliters, and 500 milliliters of the vegetable oil. And this, let me take this out for a second. This is actually a relatively small glass stirring shaft. You could upgrade very easily, either making it longer, putting some flares on it, or using a larger diameter of glass. I'm not going to do any of that. I'm just going to turn this on. See, at the highest speeds, you run into an issue of it drifting a little bit too much. Yeah. I increased the speed just a little bit. And at higher speeds, in something that's relatively low viscosity, having it precess, having it move off axis is an issue, but it self-corrects. And so I could spin this a little faster, and that would facilitate this. But you can hear it's knocking against the side of the beaker, but that's okay. In other words, it does that normally. And as I've been talking, you can see we are getting very good mixing. It's not perfect. You can see there's still about an inch, maybe 2 inches now, of oil at the top. And this really gets to where we are as far as the limitations of this particular stir design. Now what I'm going to do is I'm going to shut this off, and then I'm going to give it some time to settle, and then I'm going to replace this smaller glass stirrer with this much beefier one. This is, I believe, 7 millimeter diameter borosilicate glass, and this is 4, and you can see it's got a little indentation there for the hook, and it's got these big feet, so you can see obviously oil and water is going to separate. So I'll give that about 5 minutes to fully separate, and then switch over to the larger stirrer shaft. I've replaced this 4 millimeter glass stirring shaft with a 7 millimeter glass stirring shaft, which again is about the same length, about 6 inches, but it's got the feet on the end, and obviously it's 7 millimeter diameter. This beaker's been sitting for about 10 minutes, so the oil and water phases have separated. The bottom of the glass stirring shaft is right below the oil, right at the water interface. I could raise up the beaker, but it's really not going to be necessary, at least I don't think it will be. So now, moving it just a little bit to make sure it's centered. Okay. Now I'm slowing it down because, again, it's banging against the side of the beaker. That, unfortunately, is normal when you've got, you know, the feet kind of sticking out for something like this size. So this seems pretty stable. And just again, visually, you can see we have very good mixing at a relatively slow rate. This, of course, is not even close to being optimized in any shape, form, or fashion, but it demonstrates the capability of this particular design. So here I'm just mixing oil and water in a 50-50 ratio, and it's a 1 liter of liquid total, 500 mils of water, 500 mils of oil, and the stirrer is very capable of handling it. Those feet on the bottom, I think I made this particular stirrer myself. They could probably be optimized by, instead of having them angle straight out, could probably angle them at 45 degrees, and that might actually help stabilize it. But again, these are the type of things that you could do in your lab without very much difficulty as far as optimizing your stirrer. But truthfully, I would never really envision using this mechanical stirrer for something of this volume of 1 liter of liquid. Obviously it works. I don't have any particular application for it, but it's capable. And could you scale up further? Possibly. Again, depending on what you're trying to do. So this, again, is something that is very useful of being able to use this mechanical stirrer for various applications and volumes and so forth. Again, typically this is what we use for the ferrofluid experiment. It's a tall form 300 ml beaker, and we're usually less than 150 milliliters of solution in a typical experiment.